This is part 2 of lesson 3-4. We're going to do the word problems and we're going to do what's called special solutions. So I'm going to start here where it says, in a community garden, if you want to fence in a vegetable garden that is adjacent to your friend's garden, you have at most 42 feet of fence. What are the possible lengths? So I'm going to write down here L equals length. When it says relate, a lot of times you want to take a minute and maybe like draw a picture if you can, kind of get your head wrapped around it. Take a minute right now, pause the video, and see if you can draw a picture of what that might look like. So far, this is the only information that we have. We know that we've got these two lengths. We know that it's going to be up against another garden and that the total is 42. What is missing here and would have been kind of helpful for you to know is that this is 12. So if you're thinking to yourself, something's missing, you're right, something was missing. But you did have enough information to kind of get us here. So if I want to find the total perimeter is all the way around. So I'm going to say I have two L's, I have two 12s. You could write that as two 12s or you could write 24. And then I have at most 42. Now, when you see the term at most, you would make the number after it be the most. A lot of times you think that you should have a greater than sign, but you're trying to say that the number after it is the most. All right, I'm going to start simplifying and solving. So I'll have 2L plus 24 is less than or equal to 42. I'm going to subtract 24. 2L drops down. And I have 2L is less than or equal to 18. I'm going to divide by 2. And my length can be any number that is less than or equal to 9. Throw on feet. We would assume 0 probably wouldn't be used, but we will leave it right here. We'll talk a little bit about boundaries later in the year and how you set up, how you tell people they can't have something less than 0. If you want to make a banner that is 18 feet long and you have no more than 48 feet of trim for the banner, what are the possible widths of the banner? I want you to take a second right now, pause the video, and see if you can draw a picture of that to relate to it. Can you draw a picture that relates that situation? Trim is like saying you have a perimeter again, not area, but perimeter. Area would be the paper that you might use. You have 18 for the length, the width we don't know, and it gives us this boundary of 48, this limit of 48, and it says that you can have no more than 48. So I'm going to start by writing that 48 down. I'm going to say I have two widths and I have two 18s. You can start by just writing the 36 right away. If this can't be more than 48, what it's telling me is that this cannot be bigger than 48. 48 must be the biggest. If it can't be more than 48, kind of makes you think it might be able to be 48. So I could say equals. I'm going to start solving. 2W plus 36 equals 48. Not equals, less than or equal to. Subtract 36. 2W is less than or equal to 12. You'll divide by 2. And you'll have the width can be anything less than or equal to 6. Oh, feet. Okay, turn the page. We're going to talk about these special solutions. In equation solving, we had identity, and we had no solution. No solution is still a thing. Identity now, instead of saying they are identical on both sides, they're actually, it gives you a number that would be all real numbers because you're thinking of if they're identical, they cover everything. It would be it covers everything on the number line. So instead of saying identity or as they are identical, it would fill the entire number line if you tried to do it, if you tried to make the graph for it. We're going to start by distributing. So I'll have 10 minus 8a is greater than or equal to 2 times 5 is 10, and 2 times 4 is 8. Now, right here, when you take this 2 times 4, remember to think of it as a minus. Also, remember, If you were thinking to yourself, I can't multiply that because it's got a variable and there isn't one, you can multiply things that are not like terms. All right. Now I'm going to try and get my variable to one side. So I'm going to add 8 and add 8. When I do that, I end up zeroing out my variables. Remember, don't write 0a. Later, it makes you think you can divide by 0. It makes you oftentimes think a is still there. Just get rid of it completely. 10 drops down. 10 is greater than or equal to 10. Now the question is that a true statement? Because if it's all real numbers, it has to be true. If it's no solution, it has to be false. So if I look at this, 10 isn't greater than 10, but it sure is equal to it. So this is a true statement. Don't write the word true. Write all real numbers. If you tried to graph this and this a solution on a number line, it would cover the entire number line. Let's take a look at our next one here. We don't have distributing. We do have some like terms to combine. So if I had 7m minus m over here, that would give me 6m plus 7 drops down. Start with your variables first. So I would subtract 6m and subtract 6m. That zeroes out and that zeroes out. I'm not going to write 0m. I'm going to bring down this minus 5. And is that really greater than 7? Well, it is not. So I would say no solution. You could write NS for no solution as well. That would be fine. Remember, don't write true and false. That's just a way of you being able to identify it. I want to show you something really quick here. If you were to do this same problem and you wanted to say, I'm going to add 5 to both sides, you would then say I have 6m is greater than 6m plus 12. You would then subtract m. That would zero out. Don't say 0m, just say 0 is greater than 12. And is 0 greater than 12? It's not. You'd say no. If you don't start with the variables first, you sometimes wind up with these zeros that can kind of mess with your head. If you ever eliminate everything from a side, put a 0 there to hold that spot. All right, let's turn to the next page, right up here. I need to combine this 5n. I need to get rid of 1 or combine them. So I'm going to say minus 5n, minus 5n. So I'm getting rid of that one. I end up getting rid of both of them. 9 drops down. And is 9 less than negative 1? No, so that would be a no solution. I have some variables to combine here. I have 7x minus x. So I'll have 8 plus 6x is greater than or equal to 2 plus 6x. Start with your variables. Subtract 6x on both sides to move or combine them. You'll drop and get 8 is greater than or equal to 2, which is true. So don't write true, write all real numbers. One thing to also keep in mind, hold on. Sorry about that. One thing that you want to keep in mind when you are working is that at some point you are going to know the right answer. You're going to know whether it's no solution or all real numbers. You need to prove it. Remember, it's not your job to just give the answer, it's to prove the answer. So if you get here and you're like, oh, that's going to be a no solution, that doesn't mean that you stop there. If you get here and you're thinking that's going to be all real numbers, you don't stop and just write all real numbers. You get rid of your variable. You show by getting it down to one number on each side. Okay? All right, that's it for lesson 3-4.